Namaste children. How are you all? Fine. I hope you are fine and be safe. Stay in the home. So in the last class we discussed one method to find the square roots of numbers. Can anybody say? Yes, it is prime factorization method. And now we discuss one more method and its applications to solve some of the problems like we have one problem from our exercise 6.3, question number 8. See the question. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. So there is a garden. In that garden 2025 plants are planted. How they are planted? Are they planted irregularly? No, they are planted in rows. Some rows, we don't know how many rows are there. And in each row, how many plants also are there, we don't know. But a condition is given between rows and the number of plants in each row. So the number of plants in each row is equals to number of rows. It means that if there are 5 rows are there, then how many plants are there in each row? 5 plants are there. So total plants will be how many it is? 5 into 5, 25. If there are 10 rows are there, 10 rows are there, and in each row how many plants are there? Again it is 10. Therefore total number of plants is equals to how much it is? 10 into 10 it is 100 plants are there. Similarly, if there are 50 rows are there, and how many plants will be there in each row? Yes, it is 50 plants are there. So total number of plants how many will be there? 50 into 50 will get 2500 plants. So here in this question it is given how many plants are there in each row, those many rows are there. So we need to find the number of rows and number of plants in each row. What we need to find? Number of rows and number of plants in each row. So as we don't know, we will represent with a variable. Let that variable is x. Let the number of rows in the garden be x and number of plants in each row also it is x. So total number of plants in the garden is equals to number of rows into number of plants, that is x into x. So now write step by step. So how many plants are there in the garden? Total number of plants. Total number of plants in the garden is equals to 2025 plants are there in the garden. Let the number of rows be x. What about the number of plants in each row? That is also x. The number of plants in each row be x. Why it is both are equal, both are x by taking? Because it is given that how the plants are arranged. Each row contains as many plants as the number of rows. How many rows are there? Those many plants are there in each row. That's why we are taking number of rows is x and number of plants in each row is also x. Therefore total number of plants in the garden. Total number of plants in the garden total number of plants in the garden is equals to what it is? Number of rows into number of plants in each row. Number of plants in each row, that is equals to how many rows are there? X rows are there, and how many plants are there in each row? It is again x. X into x, it is x square, and it is given that how many plants are there in the garden, which is equals to 2025. Therefore x is equals to 2025. What we need to find here? X we need to find. To find x here, x is nothing but what? Square root of 2025. X is nothing but square root of 2025. To find the number of rows, in other find the square root of 2025 by using prime factorization method. 2025. So what is the unit place digit of this number? It is 5 is there. So hence this number is divisible by 5. So divide with 5. 5 4s are 20. 20 minus 20 0. Then bring 2. 2 is not divisible by 5. We need to bring the next digit. It is 5. So before bringing the second digit, we should keep the 0 in the quotient. Then bring 2 digits 25. 5 5s are 25. Now what is the quotient here? It is 405. Again in the unit space we have 5 is there, therefore it is divisible by 5. Divide with 5. 5 8s are 40. 40 minus 40 0. Then bring next digit 5. 5 1s are 5. Now the quotient it is 81. 81 is an odd number and we have in the unit space 1 is there, so it is not divisible by 5. Check for 2 whether it is divisible by 2 or not. It is not divisible by 2. Why? Because it is an odd number. Then what is the next prime number? 3. Check whether it is divisible by 3 or not. What is the divisible rule for 3? Sum of all the digits of a given number is 3 or multiple of 3, then that number is divisible by 3. So add the digits. 8 plus 1 9. 9 is a multiple of 3, therefore it is divisible by 3. Divide with 3. 3 2s are 6. 8 minus 6 2. Then bring 1 21. 3 7s are 21. Again 27 odd number, and it is not divisible by 2. Check for 3. 2 plus 7 is 9 and it is divisible by 3. 3 9s are 27. 9 we got, and then it is divisible by 3. 3 3s are 9. The last number we got 3, which is a prime number. So these are the prime factors of 2025. Now 2025, the prime factors of 2025 are 5 into 5 into 3 into 3 into 3 into 3. If you observe the prime factors of 2025, 5 into 5, one pair, 3 into 3, other pair, again the last pair 3 into 3, we have 3 pairs of prime factors are there. Now square root of 2025 is equals to the product of one prime factor from each pair. Write one prime factor from each pair, that is 5 from 5 into 5, and from this 3, and from here it is 3. The product of these 3 factors, 5 into 3 15, 15 into 3 is 45. Therefore square root of 2025 is equals to 45. What 45 represents? 45 is nothing but square root of 2025. Square root of 2025 is nothing but x. What is x again? The number of rows or the number of plants in each row. What we need to find? Find the number of rows. Therefore the number of rows is equals to 45 and the number of plants in each row is equals to 45. Therefore the number of rows is equals to 45 and the number of plants in each row is equals to 45. So like this we find the number of rows and number of plants in the garden. So finally the number of rows are 45 and number of plants in each row it is 45 only are there. Now can you say one or two situations where do you find this kind of problems? Where do you find this kind of problems? For example, so when we donate money to PM Relief Fund or CM Relief Fund, Chief Minister Relief Fund, so we get like situations. There is a class in one school, we don't know how many children are there. They donate money as the total number of students, how many students are there in that class, that many rupees will be donated by each student. Then what is the amount donated by each student and how much money, how many strength is there in the class, we will find that one. That is one of the example. And also when we go for PT drill, so our PT master will ask you to stand in the number of rows. So he will say, sir, the rows should be equals to number of students in each row. In such situation we will find how many rows are there and how many students are standing in each row. So like this kind of problems we will discuss in this way. Right, now we will discuss one more sum. Question number 10 from exercise number 6.3. Find the smallest smallest square number that is divisible by each of the numbers 8, 15 and 20. Smallest means least. Square number. What is a square number? The product which we get by multiplying a number by itself is known as a square number. So here our question, three numbers are given 8, 15 and 20. We need to find one smallest number that should be a square number and it should be divisible by all the three numbers 8, 15 and 20. So in 6th class you might have come across a similar question, but smallest number. Find the smallest number, not square, in 6th standard. Find the smallest number or least number or greatest number that is divisible by each of the numbers 8, 15 and 20. You have come across two types of sums in 6th standard. Least number as well as greatest number. Now here this is also similar to that sum only, but we have to find that number, smallest number. It should be a square number. Find the smallest square number. You forget for sometimes square. Find the smallest number that is divisible by each of the numbers 18, 15 and 20 means what we will do? The smallest number is nothing but the LCM, that is least common multiple of 8, 15 and 20. So that LCM will give you smallest number that is divisible by 8, 15 and 20. If that LCM is a square number, then that number will be smallest square number. If that is not a square number, we need to convert that number into a square number. How? You need to find the prime factors of that LCM, then identify the prime factors which are not paired. So next, if you multiply the LCM with the product of not paired prime factors, that product will give us smallest square number. So in solving this kind of sums, there are two major steps are there. First step, we need to find the LCM of the given numbers. Then we should identify the LCM is a perfect square or not. If it is a perfect square, the number itself is the LCM itself is the smallest square number. If it is not a perfect square number, then what to do? We need to identify the prime factors which are not paired for that LCM. So that LCM is multiplied by the product of non-paired prime numbers or prime factors. The product which we get, the new product which we get is the smallest square number which is divisible by 8, 15 and 20. Now we will discuss in detail. Given numbers are, what are the given numbers? Given numbers are 8, 15 and 20. Now LCM of 8, 15 and 20 is, find this LCM, 8, 15 and 20. So here 8 and 20 both are even numbers. So these two are divisible by 2. Divide with 2. 2 4s are 8. 15 is not divisible. So write 15 as it is. 2 1s are 2. 2 zeros are 0. Remainder is 0. Next 4 and 10 both are even numbers. So 2 2s are 4. 15 is not divisible. So write 15 as it is. Then 10 is there. 2 5s are 10. 10 minus 10 it is 0. Again 2 is there. Here we have divided with 2. 2 1s are 2. 15 is not divisible and it is 5. Next 15 is there. 1 plus 5 6. It is divisible by 3. 3. 1 is not divisible. Write 1 as it is. 3 5s are 15 and 5 is not divisible by 3. Write 5 as it is. Then see here 5 and 5. 2 5s are there. It is divisible by 5. 1. 5 1s are 5. 5 1s are 5. Now what is the LCM? LCM is equals to product of all these numbers. Prime factors 2 into 2 into 3 into 5. So how much we get LCM? It is 2 into 2 4, 4 into 2 8, 8 into 3 8 3s are 24, 24 into 5 it is 120, or 3 into 5 15, 15 into 2 30, 30 into 2 60, 60 into 2 it is 120. So 120 is the LCM. This 120 is divisible by 8, 120 is divisible by 15, 120 is divisible by 20. So 120 is the least common multiple or the least number which is divisible by 8, 15 and 20. But our question is least or smallest square number. Check. So what to do? We have to check whether 120 is a perfect square number or not. So how do you check this is a perfect square number or not? Just by identifying the prime factors. So prime factors of 120. What are the prime factors of 120? It is 2 into 2 into 2 into 3 into 5. What is a square number? Square number is a number which is obtained by multiplying a number by itself. Means a number is multiplied by itself. The products are known as square numbers. Now, see 120. 2 into 2 is one pair of prime factors, then 2 is not paired, 3 is not paired, and 5 is not paired. Here 2, 3 and 5, these three prime factors are not paired, hence 120 is not a square number, as all prime factors are not paired. Therefore, 120 is not a square number. It is not a square number. So we need to convert this 120, or we need to find a square number from 120 what? By multiplying this 120 with the unpaired factors, unpaired prime factors. What are the unpaired prime factors? 2, 3 and 5. 2, 3 and 5. So 120 when it is multiplied with 2, multiplied with 3 and multiplied with 5, what is the product which we get? The product itself is 120. 5 into 3 15, 15 into 2 15 2s are 30, 30 into 123, 12 into 3 is 36, and keep 2 zeros. How much we get is 3600. So when we multiply this 120 into 2 into 3 into 5, 5 into 3 15, 15 into 2 30, 30 into 120 it is 3600. Now 3600 is the square number. Check whether it is a square number or not. 3600 is equals to what we got? 120 into 2 into 3 into 5. 120, what are its prime factors? 2 into 2 into 2 into 3 into 5. Then what are left here? 2 into 3 into 5. Now pair the prime factors. That is 2 into 2. Here we have one 2 is there, and here we have one 2 is there. Write together we get 2 into 2. Then here 3, and here we have one 3 is there. 3 into 3. Then 5 into 5. So now if you observe the prime factors, they are paired or not. 2 into 2 one pair, 2 into 2 other pair, 3 into 3 other pair, and 5 into 5 other pair. All the prime factors are paired here. Therefore 3600 is a square number, as all prime factors are paired. All prime factors of 3600 are paired. Therefore 3600 is a square number. Is a square number. Hence 3600 is the smallest square number which is divisible by each number 8, 15 and 20. Hence 3600 is the smallest square number smallest square number which is divisible by what? Divisible by 8, 15 and 20. 8, 15 and 20. So as 3600 is a square number and it is the least number which is divisible by 8, 15 and 20. Like this we will find the smallest square number which is divisible by the given numbers. Here two major steps are there. First step is we have to find the LCM of the given numbers. The second step it is we need to identify whether this 120 is a square number or not, or the LCM which we get is a square number or not. If it is not a square number, we should convert that into square number by finding the prime factors and identifying the unpaired prime factors and multiplying with the unpaired prime factors. The product which we get, that product is a smallest square number which is divisible by the given numbers. Now I hope you understand today's two sums, and your today's homework is textbook page number 102 and 103, exercise number 6.3, question number 7 and question number 9. Complete these homework sums in the classwork, and I hope you understand today's class. In the next session we will discuss one more method to find the square roots of the square numbers, that is division method. So far we studied two methods, repeated subtraction method, the other one is prime factorization method. Until today we discussed the applications of prime factorization method to find the square roots or solving different kinds of problems. In the next class we discuss long division method, or simply it is division method to find the square roots. Why we use that division method? Here we are having small numbers, we can find small numbers, the square roots by using what it is prime factorization method. If very large numbers are there, so that method will take more time to find the prime factors. In order to overcome that difficulty, that is time consuming factor, we have the other method, that is division method, that we will discuss in the next session. Thank you, one and all.